Hi, I'm Alexis Locke.
And I'm Olivia Ramsey.
And welcome to our heat transfer project.
In this video, we would like to discuss the following components of our heat transfer project. First and foremost, we will examine the problem description we created. After, we will talk about the assumptions made when solving our problem. Next, we will show the equations that were used in order to arrive at a solution. Then, we will display our findings. Once the results are shown, we will briefly discuss the correlations in the data. Lastly, we will conclude our project presentation. For our heat transfer problem, we chose to examine the heat lost during the cooling process of chocolate chip cookies. In order to adequately analyze the process taking place, we specifically looked at the correlation between heat lost and the size of a particular cookie. In addition to this, we analyzed the correlation between the heat lost and the initial surface temperature.
Here's a table which shows the parameters used in our study. Throughout the entirety of this project, our room temperature remained constant at 23 degrees Celsius, while the surface temperature of the cookie ranged from 80 to 95 degrees. Our project was also split up into 4 series of experiments, where within each series the surface temperature remained constant, while the diameter ranged from 0.065 meters to 0.075 meters, and the height of the cookie remained constant at 0.01 meters.
Before we could solve the problem, we had to make some assumptions. The first assumption we made was that the convection coefficient was approximately 10 watts per meter squared times Kelvin on the top and for the side surfaces. Next, we assumed that the convection coefficient for the bottom surface was approximately 5 watts per meter squared times Kelvin. After that, we assumed that the emissivity of the cookie surface was 0.8 on all sides. Additionally, we neglected the effects of heat loss due to conduction. Finally, we assumed that a cookie is thin enough to maintain a uniform temperature throughout the cooling process.
Here are the equations that were used in our project. In order for us to determine the total amount of heat that was lost, we first had to determine how much heat loss was due to convection and how much heat loss was due to radiation. The top equation was then split up into 4 separate equations in order for us to figure out the convection on the top, bottom, and side of the cookie, as well as the radiation on all sides.
Here are the calculated results from the experiment conducted in this project. As you can see, the smallest and largest heat loss values are labeled on the chart. The smallest occurred at an initial surface temperature of 80 degrees and a diameter of 0.065 meters, while the largest happened when the initial surface temperature was 95 degrees and the diameter was 0.075 meters.
Using the results we found from this experiment, we were able to plot 2 graphs using Excel. In this first graph, we plotted heat loss as a function of diameter, and as you can see, there is a positive correlation showing that the magnitude of heat loss increases as cookie size increases. In this second graph, heat loss was plotted as a function of initial surface temperature. As you can see from this graph, there's a positive correlation as well, which shows that high initial surface temperature yields a high magnitude of heat loss for all cookie sizes.
In conducting this project, we learned firsthand just how applicable heat transfer is to everyday life. This experiment also taught us that heat loss is dependent on numerous factors. Lastly, we'd like to conclude with the recommendation of baking cookies to physically observe and better understand heat transfer processes.